So, good morning, good afternoon, and good evening, everybody. We appreciate you joining us today for our near neutral descaling webinar, where we'll be focusing on improving paint performance in welding and laser cutting operations. So, let's begin. The first topic that we'll cover today is the necessity for scale removal. So if we're talking about weld and laser descaling applications, the first point of failure is of most importance here, and the importance of weld and laser scale removal is frequently ignored or considered too difficult or too dangerous to solve in paint pretreatment systems. As a result, the welds and laser cuts are often the first point of corrosion and paint failure. So the most common first point of failure of paint coatings is at the welds and the associated heat affected zones, which we'll see a little bit later, as well as the areas of inorganic scale, such as those created during laser cutting or plasma cutting operations. The scale formed during these processes prevents any organic coating, being E-coat or KTL, wet paint, powder paint, or any combination of these, from adhering to the substrate surface properly. And traditional alkaline cleaners or degreasers are incapable of effectively removing this weld or laser scale. So here are some examples of laser and weld scale that we see in the industry. So looking at the left, you can see in the top image that there is a laser cut part that is showing the dark areas is exhibiting the oxide scale that is creating during the laser cutting operation. If you move to the image on the bottom, you can see the similar aspect where we see the dark areas of the oxide scale on the top part. But for the bottom part, we can see that this is a part that has been descaled, and you can see that all of the oxide scale from the laser cutting operation has been completely removed. If we move to the right side of the page, this exhibits a traditional weld, seam weld. So in the middle, this is the weld seam with the silica inclusions. Moving to the outside areas, like we referenced in the previous slide, you can see the weld burn or heat affected zone. And then lastly is the metal substrate itself. So often applicators in the paint industry ignore this problem, being the poor adhesion of paint for weld and laser cut areas. So during paint performance evaluations, the adhesion and corrosion near welds, edges, and laser cuts are often not evaluated or completely ignored. For electrophoretic paints, being E-coat and KTL, it will not completely cover or adhere to these scales, so it is often touched up with further painting. This creates a couple of problems because when you do this, there's of course an added cost for paint, added cost for labor, and still this is often the first point of failure due to the thinner paint coating. So looking at the right side of this page, you can see in the top image where we show some of the silica inclusions along the edge of the weld itself, where we have very poor coverage of the E-coat paint. And then the image on the bottom is a part that had been E-coated and then wet painted. And you can still see, even with the addition of the wet paint, that the weld joint area is still the first point of corrosion. So next, we'll talk about the understanding of existing scale removal methods, being conventional methods that are used in the industry today. So the first descaling option is what we refer to as mechanical method. So some applicators remove oxide scale using mechanical methods like media blasting or grinding. However, this can create several issues for applicators. The first and probably most important is the severe HES risks that are associated with these. Of course, these can create serious accidents. The most common are to the hands and eyes, but also can include body injuries as well. Because of the noise pollution created with these applications, it can result in hearing loss. There are also repetitive strain injuries that can be associated with this, especially for those that are manual applications. And then inhalation hazards from the dust that is created from the oxide scale removal. These processes are costly. They are very labor intensive, especially the manual applications. Due to the nature of the application and the stress that it puts on the equipment, it often results in a very short equipment life. It does create some damage to the substrate and the surface profile that can result in paint defects or a change in the aspect of the paint coating itself. It does generate dust and debris, which is a potential contamination source for paint applications, which again can be can result in a lot of defects. And then lastly, there's line of sight issues, and this is mostly associated with complex part geometries. And those parts that have recessed areas where the weld, laser cut, or heat affected areas are not immediately visible to the either the equipment or the applicator. The second method, conventional method for descaling, is chemical with strong acids. So some applicators will use these strong acids to remove the oxide scales. However, these dangerous chemicals, when operated at elevated temperatures, can result in chemical burns to the skin, eyes, and respiratory system, especially if there's not the appropriate ventilation equipment that's installed with the process. And it, of course, can result in near misses and serious incidents as well. These strong acids are not safe to spray in conveyor systems or hand wands. And this is mostly because of the fact that it exposes the employees to these hazardous chemicals, and it can result in corrosion of the equipment and the factory as well. One of the other issues is that it results in etching of the substrates, which results in a buildup of iron, which leads to a short solution life. Other issues and costs associated include the disposal of the spent acids, as well as a burden on the wastewater treatment regulations. Now we'll talk about selecting the appropriate process for descaling. So the most economical option for oxide scale removal is in the paint pretreatment process itself. So some of the advantages with implementing the oxide and scale removal directly in the pretreatment process include avoiding the labor and safety costs of mechanical descaling. Again, media blasting requires a higher capital investment and results in short equipment life. And the manual grinding requires intense labor and can lead to many injuries and near misses as well. You can minimize the necessity and cost of inert atmosphere laser cutting. So this is an expensive capital investment, and if not operated properly, it can still create and generate the oxides that are present with normal laser cutting operations. Strong acid descalers are limited to immersion applications due to their safety concerns and the short equipment life. And then lastly, extra stages for either immersion or spray applications often require a relatively small capital investment and low operating costs. So this is very easily achieved for new line builds. It is possible for existing lines if the factory has the floor space, either adding additional stages to a spray washer if this type of equipment is being used, or using offline immersion application to achieve the descaling as well. So, however, selecting this route does not necessarily mean that the optimal process or product has been selected. Some proprietary chemical descaling solutions can have several disadvantages associated with them, just like what we've seen with the other conventional methods. So some contain hard chelating agents, which is a significant burden on wastewater treatment, especially for facilities that are doing painting and plating at the same time. There are some of these have very high etch rates, and what this results in is a very short solution life. Some applicators will implement a feed and bleed type system where they send off some of the solution and replenish with new. But again, this results in more chemistry being sent to wastewater treatment. And both of these result in a much more expensive wastewater treatment operation. There are risks of flash rusting, as you can see exhibited in the image on the right side of this page. Some offer incomplete oxide or scale removal. We still see poor paint adhesion with some of these, and they can be less compatible in multi-metal applications as well. Now we'll discuss Uniprep AC, which is Atotech's line of near-neutral pH descaling products, our sustainable alternative to the conventional methods we've discussed already. So Uniprep AC is truly a superior approach to laser and weld scale removal. So it can operate at near-neutral pH, resulting in less substrate etching, which leads to process savings through longer solution life and lower wastewater treatment costs. It contains surfactants to allow cleaning in one step when necessary. For the best results, alkaline cleaning is really recommended prior to descaling to remove the organic soils that are present on the part before doing the inorganic scale removal. But ongoing process innovations to achieve superior cleaning and descaling in one step is underway. And this is ideal for existing lines with limited chemical stage capacity. This would potentially allow applicators to not add additional stages to their application, but using a descaling chemical like Uniprep AC as a drop-in solution for both organic and inorganic removal. Improved paint and pretreatment quality can be achieved through improved scale removal. There's a minimized risk of flash rusting. It's free of strong acids such as phosphoric acid and fluoride compounds. It's also free of alkyl phenol ethoxylates or APEs, which have seen an increase in global restriction in recent years. So Uniprep AC also offers a very low etch rate for both steel and zinc surfaces. At new makeups, what we've seen in some of our lab evaluations is an etch rate on steel of 0.1 grams per square meter per minute. And for zinc surfaces being galvanized substrates and the like, an etch rate of about 0.5 grams per square meter per minute. It also offers a significant benefit over some commodity-based chemistries like hydrochloric acid. You can see here the risk of hydrogen embrittlement is very low or zero as compared to a hydrochloric acid pickle or descale. So it also offers improved e-coat coverage. So for electrophoretic paints, they often have poor performance on weld and laser cut scales. These inert scales lack electrical conductivity and therefore the coverage as well. Poor adhesion and corrosion resistance around the scales and burns is also an issue. So weld and laser descaling can greatly improve the e-coat performance on these scales. Decreased requirement, what this results in is a decreased requirement for touch-up paint and improved paint performance as well. So you can see in the images on the bottom, we see another laser cut scale part. This is before e-coat. And the image on the right is the weld scale and burn area before e-coating as well. So these areas would present issues if they were not addressed prior to pretreatment and the e-coat application. Talking about some of the potential pretreatment line configurations with implementation of Uniprep AC along with Atotech's other pretreatment chemicals. So the ideal descaling pretreatment line setup results in the use of our Uniprep alkaline cleaners or degreasers, Uniprep AC descalers, and interlocks zirconium conversion coatings. The ideal line setup is 7+ stages, and this is optimized pretreatment and descaling for the highest level of performance. So you can see in the line diagram in the bottom of this page, first we start with the Uniprep alkaline cleaning prior to rinsing. Then we would move to the Uniprep AC descaler, rinsing, the interlocks conversion coating, and then 2 more stages of rinsing prior to going to dry off and paint application. However, there's other ways of achieving this as well. A flexible descaling pretreatment line setup could look like this. So again, it would implement the same products, but in a different order. So you can see the use of Uniprep AC descalers, Uniprep alkaline cleaners again, and the interlock zirconium conversion coatings. This type of setup would be good for 5 or 6 stage washers. So you can see in stage 1, we have implemented the Uniprep AC descaler. Then we move immediately to the Uniprep alkaline cleaner. Because of the pH of the descalers, going immediately to the alkaline cleaner will not have much of an impact on the process control because it is operating at relatively near neutral pH. Then we move to a rinse before the interlock conversion coating, additional rinses, and then again to the paint application, or sorry, the dry off and paint application. So now we'll cover some of the scale removal evaluations so we can see how these processes perform. So one way to evaluate and compare the cleaning of scales is to immerse the part in an auto deposition copper coating solution or an electroless copper process. So a clean surface is going to leave a bright, consistent, and adherent deposit of the copper on the part surface. So the image on the left, you can see this is a part that has had no descaling done at all. And the coverage on the weld itself is not very good. You can see that it's not bright. It's not complete coverage of the weld itself. As we move further to the right, showing some competitors' descaling processes, again we can see, as we referenced earlier, incomplete descaling of the oxide scale on the weld itself. And this is exhibited from the copper immersion test that we can see here, that there's no coverage of the copper on the part itself, or sorry, on the weld. And then lastly, the image on the right is Atotech descaling with Uniprep AC. And we can see that we have very good coverage. It leaves a bright and consistent deposit on the part and is completely adherent to the weld itself. So also what we referenced earlier was some of the burn areas or heat affected zones. So as you can see here in the image, we show 3 different parts. One is as received. So this is a raw part with no chemical treatment done to it at all. The 2 images on the right will compare a clean only application to a clean and descaling with Uniprep AC. And you can see with the addition of the Uniprep AC for descaling, there's a notable elimination of the burn areas, which would typically require manual grinding to remove and to get good adherence. Talking about laser cutting scales, benchmark testing of the Atotech descalers with Uniprep AC as compared to mechanical grinding. You can see the panel 1 image on the bottom left. This is a part that had been mechanically ground. Panel 2 is the Atotech process with Uniprep AC. And then lastly, panel 4, which is the clean and coating with no descaling. You can see that panel 1 and panel 2 are very similar in performance, showing that the descaling is offering very similar results to the mechanical grinding without all the associated negative impacts that come with that. You can see that in panel 4 that that we see some paint loss from the impact areas, and this is exhibiting poor performance and poor coverage of the paint on the laser cut edge. Again, some more examples similar to what we saw earlier. So the image on the part on the left will exhibit a clean only application where we see that the oxide scale is still on the laser cut edge. The part on the right is showing the cleaning and descaling where we have complete removal of the oxide scale. If we show these parts after the copper immersion evaluation, we can see that again the coverage on the oxides is minimal or none at all. And with the implementation of Uniprep AC, we get extremely good coverage on the laser cut edge because of the complete removal of the oxide scale. What this results in from a paint standpoint is the clean only part, we see some significant paint loss from impact evaluations. And with the implementation of Uniprep AC to this process, we see very good paint adhesion, absolutely no paint loss from the impact zone. Talking about some of the corrosion evaluations of welds. So this particular study was on parts before and after near neutral descaling, and they were e-coated and then submitted for neutral salt spray evaluations. The e-coat paint thickness on these parts was about 15 to 20 microns. So the image on the left you can see is a part that was cleaned only and was submitted to neutral salt spray for only 336 hours. The part on the right is clean and descaling, tested up to 840 hours. And you can see from the clean only part that we have some pretty significant paint loss along the weld area. And for the part with cleaning and descaling with Uniprep AC, we can start to see some corrosion at 840 hours, which is to be expected. But we see that there's significantly less paint loss, showing that the implementation of the descaler is offering a significant improvement versus the clean-only application. So these descaled samples consistently showed much less rust and paint loss at the weld areas than parts that were only cleaned. Again, going back to what we referenced earlier about the burn areas. So these parts are welded. And if you look here, this area right here is actually on the back side of the weld itself. So this is the burn area that you would see from some of the other parts. What we also did is we did a scribe along the non-burn areas of these parts too, to evaluate how the performance would, what we would see from the performance in the non-burn areas. So what you can see from the clean only application is that the non-burn area does have some paint loss, but at the burn areas, we see significant paint loss and delamination of the e-coat paint. As we move over to the part with Uniprep AC added to the process for descaling, you can see that the non-burn area is showing some improvement, but not a lot in comparison to the non-burn area. But we see that for the burn area, as compared to the clean-only part, we see a significant improvement. And what we also see is the fact that the non-burn area and the burn area of these parts are exhibiting almost identical performance, showing that the addition of the descaler is really improving the overall part performance. So to discuss a little bit more in depth some material science related work that we have done. So these are parts, again, before and after the near neutral descaling, where we have conducted some EDS analysis. So for the clean only part, we can see that the significant elements that we want to focus on here are oxygen for the oxides, as well as silica and manganese. And for as we move to the right sides, being the clean and descaling, we can see that the oxide, the oxygen content for the clean and descaled part is reduced significantly. Also, we see the same with the silica and with the manganese. And so these significant decreases in these elements are directly attributed to the oxide removal. And what we can also see here is a corresponding increase in the amount of iron that is available from the EDS analysis. Now we'll cover a couple of case studies. So case study one is a North American transportation manufacturer. So in 2016, they were building a new pretreatment line and desired a chemical descaling solution. Their prior application utilized manual grinding, but had a lot of safety concerns. So they needed e-coat with good paint performance on the welds. And as I mentioned, they dedicated 6 people to grinding all of these welds, burns, and cuts. And it resulted in an average of 4 safety incidents annually. The strong acids strong acids were regulated for this site, and could not be used. So the solution for this applicator was implementation of Uniprep ACD 105, which is our near neutral pH weld and laser cut scale remover for immersion applications. What this offered for the transportation manufacturer was improved e-coat coverage and paint performance. It offered a P-free, APE-free solution with minimal etching of steel. It was safe and easy to use and improved their waste treatment. And what they were able to achieve with this is greater than 400,000 US dollars per year in savings, attributed directly to the implementation of the near neutral descaling itself. So the second case study is a European agricultural manufacturer. So their prior proprietary descaling process had several associated disadvantages. It had a very high cost due to the high etch rate, requiring approximately a 25% tank volume feed and bleed on a daily basis. Poor paint coverage and corrosion resistance was often observed for the welds, laser cuts, and plasma cuts. With implementation of Atotech descaling with Uniprep AC, the following improvements were realized. So they were able to reduce the etch rate by about 40 to 50%. There was less burden on wastewater treatment. It reduced their reject rate by about 80%. It improved their part quality and flash rusting. And it allowed for the capability of producing cast iron parts, which they were previously not able to do. And it helped improve their overall plant efficiency. So if we look at the image on the right, this is a plasma cut edge that they normally had a lot of issues with. And so you can see with the evaluation done here that there's absolutely no paint loss from the crosshatch test. And what you see with the gray area here is actually with what was done here is they manually tried to remove some of the squares from the crosshatch area. And this is just the scratching of the top layer of paint. So that's not actual paint removal. It's just scratching from trying to manually remove the paint from the crosshatch area. So another improvement that they were able to achieve was significant reduction in the burn areas, which did present some issues to them in the past. So the image on the left you can see is a welded component prior to descaling and pretreatment. So you can see along the welded areas right in here, we see a significant amount of the heat affected zones from the welding applications. If we look at the image on the right, what you'll want to look at is along the bottom area here. This is the welded component after descaling and pretreatment. And you can see almost complete removal of the burn areas and heat affected zones, which again presented a significant issue for them in the past with their other proprietary chemicals. The last case study is with a Japanese automotive OEM. So this OEM evaluated Atotech's descalers, being Uniprep ACD 105 at 150 grams per liter and 50 degrees C to determine the feasibility of replacing the existing process for E-coat applications. So their evaluation method was with cyclic corrosion, and 50 cycles is equal to 1 year of exposure for them. So you can see here in on this part, the area of evaluation is right here along the welded area. So the top part, as we move to the left, we can see with the existing process and no descaling that we start to see some significant rust along the welded areas right in here. As we move further to the right with the implementation of Uniprep ACD at 2 minutes application, we can start to see some reduction in the amount of rust that is exhibited along the welded area. And lastly, as we move to the Uniprep ACD 105 application, that at 5 minutes, we can see an even greater reduction in the amount of rust along the welded area. So the existing process exhibits red rust after about 1 year simulated cyclic corrosion testing, and the implementation of the Atotech descaling extended the first presence of red rust to 3 years simulated cyclic corrosion testing. So the addition of the Atotech descaling ended up resulting in about 44% less corrosion depth at the welds, which is quite significant for them. So in summary, Uniprep AC can improve the paint performance on the first point failure. It offers a near neutral pH solution for applicators. It also offers a multi-metal solution. It reduces the overall wastewater treatment and issues that are associated with it. And lastly, it can improve the overall cost savings for the process as well. So thank you.
Thank you, Brenton. We will now proceed with our Q&A session. I would like to remind you that we will cover as many questions as possible during our Q&A session, and all the rest will be answered by Brenton after the webinar via email. So I would say let's start. Brenton, the first question for you. What pH range do these products operate at?
Sure. So typically at operating concentration, these products being Uniprep ACD 105 for immersion applications and the ACS 100 for spray applications, they operate around a pH of about 4.5 to 5.5.
Thank you very much. Second question, can these processes be applied by immersion?
Yes, absolutely. So Uniprep AC products are capable of being operated in both spray and immersion applications. So for spray applications, there is the Uniprep ACS 100 that I just referenced. And for immersion applications, we have Uniprep ACD 105. Each of these products are designed for optimal performance in their respective application type. And this offers greater process versatility. So the decision of whether to use a spray or immersion product will really be dependent on the part type and the dimension, as well as whether the customer applicator has existing equipment or is planning to build a new system for descaling. So, for instance, for very large components, an immersion system might be preferred, but a manual spray application could also be an option as well.
Thank you. What is the application time for the neutral pH descalers?
So the application time really can vary from one application to the next. And this depends on the amount of oxide scale that needs to be removed, as well as the method of application. And by this, I mean, whether it's spray or immersion. So of course, longer application times should offer improved scale removal. But what we've seen in some of our evaluations is that actually increasing the temperature has shown to offer even more improvement on the weld scale removal rates as compared to longer application times or increasing concentrations.
Great, thank you so much. Are these processes safe for use on galvanized steel?
Yeah. So as we saw in the presentation, where we talked about the iron and zinc etch rates, the etch rate on zinc surfaces are quite low, and this is still while they're still offering very good scale removal. So in comparison testing with other proprietary chemistries, Uniprep AC has still had a significantly lower etch rate than some of the other chemistries that we have seen in the industry or evaluated.
Thank you very much. Can I just apply more paint to the weld to prevent early corrosion?
Yes, you could, but this could potentially create several issues. One of this is the first one is, of course, paint is very expensive. Much more expensive than the pretreatment chemicals themselves. So this would result in an overall cost per component to increase. The welds are often not in direct line of sight of the paint pistol. So you would be applying an even higher quantity of paint to the non-welded area in order to achieve the appropriate paint thickness that is desired. Applying these very high quantities of paint can also lead to undesirable paint aesthetics, poor paint cure, and even loss of integrity of the paint adhesion qualities. And then lastly, the presence of the scale is really what leads to the poor adhesion. And applying more paint will not necessarily change the ability for the paint to bond to the substrate surface that is impeded by the scale. So the premature loss of the paint can really be be a direct result of the poor corrosion itself.
Thank you very much. Another attendee would like to know, why is the burn area of a weld a concern?
Sure. So in the evaluations that we've done and some of the implementations of our Uniprep AC products at customers, we have seen that the burn area can present as much of a problem to applicators as the scale on the weld itself. So these heat affected zones appear on the front, and depending on the thickness of the substrate that's being used, can appear on the back as well. This is especially troublesome for welds on tubular pieces or those with line of sight issues, making it impossible to mechanically remove prior to paint application. So the implementation of Uniprep AC for these type of applications really offers a big benefit where line of sight is an issue for the burn areas.
Great, thank you very much. Somebody says, we use mechanical grinding to remove the scale and silica or glass in the weld. Will the chemical descalers also remove this?
The answer to this is really yes and no. The silica inclusions will be embedded at varying depths in the weld. So as the descalers remove the oxide scale, they will also remove some of the loosely bound silica as well, as we have seen in some of the SEM results that we from the slides earlier. So for those inclusions that are not removed, the integration of surfactants in the Uniprep AC products formula really offer improved organic soil removal, especially for those areas at the weld and around the silica inclusions, allowing for better bonding of the conversion coating and paint, which is this is what's helping in improving the overall paint coverage. And as a result of that, the corrosion protection for the part as well.
Thank you very much. The next question, can these be used on cast iron due to its porosity?
Yes, we actually have many customers that are utilizing these processes with cast iron, and is part of what we alluded to with the multi-metal. Meaning that it can be utilized for various types of steel, and certainly cast iron is one of those steel substrates that can be used for these type of products.
Thank you so much. Are there any wastewater treatment concerns with these products?
So for commodity-based acid descalers, there can be a very large burden on wastewater treatment, like we discussed earlier in the slides. So due to their high etch rate, the process often requires a feed and bleed type approach to keep the iron concentration low. But it still has a very short bath life, requiring frequent discharge to wastewater treatment. The Uniprep AC products have a much lower etch rate, than the commodity-based chemistries or even some of the proprietary chemistries we've seen. And what this results in is less chemistry being sent to wastewater treatment. And they also do not contain any hard chelating agents. So yes, the wastewater treatment concerns as compared to other technologies is significantly reduced.
Great, thank you so much. Next question coming in for you. Is Uniprep ACD an acid-based or alkaline-based product?
It is an acid-based product, as we mentioned in one of the earlier questions. The pH range typically is around 4.5 to 5.5.
Great, thank you. What is the bath life?
Okay. Yeah, the bath life is really a metric that is dependent on several factors of a customer's application. The first is probably the production volume. Much like with other chemical processes, more production results in quicker use of this the solution's usable life. Also, the throughput in relation to the solution volume will play a large factor in the bath life. So for instance, if you have a very high volume of production and a small tank volume, then the bath life of the chemistry would be much lower as compared to an application that has a smaller throughput with a much higher bath volume. The next point is solution maintenance. So as production throughput increases, the amount of dissolved iron will likewise increase as a result of the descaling mechanism. So proper filtration of the descaling solution and even the rinse water can keep the contamination levels low in these products, resulting in an extension of the solution life. In some applications, we've seen that the bath life can be as long as 9 to 12 months. But again, it's variable on the production volume, the throughput, and solution maintenance. So these three factors really play a key role in determining the bath life of the solution.
Thank you. Brandon, here goes the next question for you. Is a neutralizer after the descaling process needed?
No, not necessarily. What we've seen from most of our applications is that it's not necessary to have neutralization. We certainly have some customers that are using neutralization just to ensure that as they move further down the line, they're not dragging acids into additional stages. But the necessity for neutralization is not as high as what you would see with some other chemistries, especially the commodity-based strong acids.
Thank you. Let me have a look. Here goes another one. Can these products be used for plating applications?
Yeah, absolutely. So as we saw in the slides, and what was exhibited with the auto deposition copper evaluations. So this concept, obviously, we utilize it to mimic how a paint would adhere to it. But the same is true for the plated metal. And these organic scales are they react similarly for the adhesion of plated metals versus paint. So these scales still prohibit the metal from plating to the part and fully covering the area. And this can result in poor performance, whether it's for functional plating or decorative plating. And we certainly have a few applications globally that have integrated these products in plating applications as well.
Great, thank you very much. Another one. Can Uniprep AC descaling remove the thermal scale from heat treatment processes?
Sorry, could you repeat that one more time?
Yeah. Can Uniprep AC descaling remove the thermal scale from heat treatment processes?
Yeah, so similar to what we've seen with in the slides for the heat affected zones, this would definitely be achievable with these type of products. And what we saw from some of the E-coat evaluations, we see a significant improvement in the paint adhesion, especially even for the single coat E-coat application where we evaluated. We see quite a nice improvement as compared to no descaling at all.
Great, thank you. Next question. We currently have a cycle time of 1 minute. Will UniPrep AC be effective?
Yeah. So again, I think that we've somewhat answered this in a few questions, and it's really dependent on a couple of things. It depends on the level of oxide scale on the welds or laser cuts. It's dependent on the application type, if it's immersion or if it's a spray application. But the UniPrep AC products would certainly be able to remove the scales as necessary, but it would come down to finding the appropriate operating parameters to remove those scales. With such a short application, again, depending on if it's immersion or spray application, it may require elevated temperatures or a higher concentration or something like this. But with the time being stagnant, those are really the two factors that can be adjusted to improve the rate of descaling.
Great, thank you so much. So the next question is related to a slide. So I would suggest we are jumping to that slide 23.
Okay, sure.
Yeah, can you go there? Then I will ask you the question when you're there.
Certainly.
23. You're at 22 now?
Okay. Oh,
all
right, one more.
Yeah.
Yes.
Okay. Was a tape pull test used after corrosion testing on the parts shown in slide 23?
Yes, that is correct. So it was a tape test along the weld that was used to evaluate these parts. And so you can see from the clean only application on the left after 336 hours that there's quite a bit of paint that is removed from the tape test. And we see that the part that was cleaned and then descaled with UniPrep AC after 840 hours of neutral salt spray exposure, we see very minimal loss of paint from the tape test. So yeah, to answer that question, that is how we evaluated, was with a tape test.
Great, thank you. So we quickly jump back. Should I move the slides? I think that's
Sure.
quicker. So just that we don't get any confusions here.
Sure.
So the next question. How can this be installed in a 5-step washer?
So like we saw in the diagrams earlier in the presentation, normally it's preferred to have more stages in a washer if the goal is to clean both organic soils and inorganic oxides. But it is possible to accomplish this in only 5 stages. This is really going to be dependent on the amount and type of the organic soils. So those, along with the scale, they could potentially be removed in one step. We do utilize our UniPrep AC products in some applications without the addition of an alkaline cleaner for the organic soil removal. But the optimal solution is utilizing both. But further developments in these products, ongoing today, will allow for an even higher degree of organic soil removal as well. And this could potentially eliminate the necessity for an alkaline cleaner in some applications. So this would allow for adequate cleaning prior to conversion coating and painting, and would minimize the necessity for additional chemical stages added to the process.
Great, thank you so much. So next question is a bit long, so I will go step by step.
Okay.
In our company, we have sheet metal degreasing, then welding, then mechanical sandblasting, and finally enabling. Where would we introduce your product? Before sandblasting and enabling?
So for this type of application, it depend again. This really depends on the on how adherent the scale is to the weld. But it could, and like we discussed in one of the case studies, it can completely eliminate the necessity for shot blasting. Again, evaluations would have to be done in order to determine if this could be achieved or not. But that's ultimately the goal of these Uniprep AC products, is to eliminate the necessity for those type of applications. So depending on what equipment the customer has available today, you could potentially consider implementation of a small spray washer or an immersion tank to do this descaling, and could potentially completely eliminate the necessity for the shot blasting application itself prior to enamel.
Thank you so much. Next question, here we go. Is Uniprep AC capable of removing rust from the surface of a highly corroded part?
Yes, it is. It's certainly not intended for that, but it can do that. We've certainly had parts where we've done evaluations that have come in and the parts have been rusted, and it's able to remove some rust. In some cases, all of the rust. It really depends on the level of rust that is on the parts. Again, it's not intended for rust removal in that sense, but has been somewhat successful in achieving that in some applications.
Thank you very much. So I think we are coming now to the last question because we're running out of time. As I said before, Brandon will be available after this webinar to answer all the other questions via email. So Brandon, here's your last question for today. How can chemical descaling be less expensive than the low cost of grinding?
Yeah. So it is true that the cost of grinding a weld and the labor that's associated with it can be relatively cheap, depending on what region of the world you're in. But there's certainly many other costs that are associated with grinding as well. So for one, mechanical grinding, like we've discussed, can cause many injuries. Most commonly the hand and eye injuries, but can be much more significant injuries as well. It's also a very aggressive form of scale removal and can alter the substrate surface negatively, potentially creating defects, which of course we know, especially depending on the part type. If we have defects, it can be very costly. Again, there's line of sight issues. So secondary methods may still be required for complete descaling, which will of course add more cost to the process itself too. And so really all of these paired with companies and organizations' social responsibility to offer employees the safest work environment possible really makes chemical descaling with Uniprep AC a much more economical and sustainable process for applicators today, as compared to descaling or any of the other conventional methods that we discussed today.
Thank you very much. So Brandon, I would like to thank you again for the great presentation and this really interesting Q&A session. And I want to thank you, everyone. We really appreciate you being here.